Good day, everyone. I am AYU HELINDA. At this moment, I want to present our results about development of heterogeneous database synchronization algorithm based on entity relationship model approach. The rapid development of information technology caused the need of data storage media to increase. And then database management technology continues to grow and is available on various platforms. That's resulting in limitation in the synchronization process because each DBMS only provides synchronization methods for similar DBMS. The database synchronization method that is often used today is the slave master and replication method. The synchronization process in slave master is carried out from the master database to slave database. And then whereas in the replication method, database synchronization can only be created for the same type of DBMS by copying all of the data from the main database to the destination database. Main database, that is source database, to the destination database or the others. The several studies related to this database synchronization, including database synchronization for mobile device. So in the studies, the message algorithm is used to recognize change in data to carry out the synchronization process. So they are use the message algorithm to check data, to check the hash value of each row in the table, and then it performs a match against the hash value in the database table to synchronization. The implementation of this method will take a long time. It takes a long time if the synchronization data is with a large data. So this research, our research is focused on developing a heterogeneous DBMS synchronization algorithm using the entity relationship or ER model approach. So this entity relationship approach for heterogeneous DBMS synchronization process in our study, in our research. So the implementation of ER model or entity relationship model works by creating a temporary table that stores the primary key or PK of each data record in the table that change or contain new data. The flow of synchronization process is determined based on the type of transaction. The data, it will select data from the source table based on the relation from the temporary table for synchronization to the destination DBMS. After the synchronization process is carried out, the related data in the temporary table will be deleted. And then the same process is also carried out on the other DBMS as a stage in the synchronization process. And then this study is performance to the proposed method is evaluated by observing the execution time value of each synchronization process. This is an example for entity relationship or ER approach synchronization process in this study. So we use example for two tables. On the picture beside, there are two tables from each DBMS. DB1 or the database 1 and database 2 for DBMS 2. That is table A and temporal table. So at the DB1, the database 1 and database 2 have table A. The table name is table A. And that is have a temporary table at database 1 and database 2. And then table A is a table in each DBMS that will be synchronized. So the table A is data at the table A will be synchronized to table A at DB2. When the data at the table A on database 1 is changed with primary key AB, this primary key AB at the table A at database 1. When this data is changed, so at the same time, the identity of primary key AB, and then type of transaction name, and then the name of the transaction source table, it is stored in the temporary table as a reference for the list of data to be synchronized. So the primary key at table A, and then identity of the data transaction, and then the name of the transaction, all of data or on the table A at the database 1 is stored in the temporary table at the database 1. And then in the temporary table have one data to synchronize. And then the temporary table and the data source table at table A are related to each other using the primary key identity contained in the two tables. The next stage of the synchronization process is carried out by taking data from table A with primary key AB based on the same primary key attribute from the temporary table to be synchronized to database 2 of database to table A. After the synchronization process is complete, the primary key AB of the at the temporary data table is deleted. The same process is also carried out on database 2 for synchronizing data to database 1. So the entity relationship method approach can shorten the time of the synchronization process by only synchronizing data that has changed without having to check the hash value of each data, as in previous studies before. So this implementation of entity relationship model in this study, the proposed algorithm is written with using the PHP programming language. The interconnection of the two DBMS tested use a REST web service with JSON data format, and then the DBMS use or MySQL and PostgreSQL using a database source from generatedata.com. Database generate that is a database generator open source. So the first step in the test that have been carried out are determine initial variables such as bandwidth allocation and type of transmission media. In this test, the bandwidth allocation used is 100 Mbps, while the type of transmission media used UTP-5 cable. In this implementation, we test scenario carry out with two mechanisms. That is MySQL to PostgreSQL synchronization, and then PostgreSQL to MySQL synchronization. In the test of MySQL to PostgreSQL synchronization, the execution time is observed for each type of transaction. That is insert transaction, update transaction, and delete transaction in the entity relationship and message digest 5 or MD5 synchronization methods by setting the amount of data to be synchronized from 100, 1000 up to 10,000 records with the initial amount data in each DBMS has be 200 records. And then at the implementation PostgreSQL to MySQL synchronization, in this test, the process is the same as the MySQL to PostgreSQL synchronization on entity relationship and MD5 synchronization method, except that the synchronization test is carried out from PostgreSQL to MySQL. So this is, we have two tables with the same structure. with the same structure. There are the employee table and the temporary table. This is employee table and temporary table. Two tables with the same structure, the column name, type, and attribute. There are have the same structures. And then this table contains sample data that will be synchronized with each other in each DBMS. The sample data in the employee table is sourced from generatedata.com, the open source data source. The structure of the table can be seen at the table beside. The structure of two tables, this is same about between employee table and temporary table. And then this is algorithm design of heterogeneous database synchronization. This is a flowchart of heterogeneous database synchronization algorithm. The first step is the initial stage of the synchronization mechanism. Begin with checking transaction or event. The event is insert or update or delete that occur in the sync DB1 at database 1. And then if the event that is insert, update, or delete occurs, the identity of the data undergoing a transaction store in the temporary table. Insert data into temporary table at database 1. And then checking data in the temporary table at database 1, checking data at the temporary table. If the data is found at the temporary table, the next process is find or retrieve data from the source table. And at this case is employee table in database 1 based on the primary key reference in the temporary. Find data in the source table based on primary key. And then at the reserve endpoint, the received data will, and then the data obtained is encoded into JSON format to be sent via the REST web service to the REST API endpoint server on the base hosting database 2. So the data is encoded into JSON format, and then data synchronizing at to the database 2 with API endpoint. And then at the reserve endpoint, the received data will be decoded the original format. At the database 2, the JSON data, the data that is encoded before. At the database 2, the data is decoding to the original format. The next stage is checking for its type of transaction. Insert or update or delete. And then if the database, and then do data synchronization to database 2 based on type of transaction. Insert or update or delete. And then the server then sends a response to the REST client. If the transaction is successful, the data in the temporary table will be deleted and the synchronization process start again when there is new data in the temporary table. The same steps are also carried out on the database 2 to synchronize to database 1. There is pseudocodes of heterogeneous database synchronization algorithm based on entity relationship. The result of our journal, our test is our research. The result of our research is we have two results. MySQL to PostgreSQL synchronization test result and PostgreSQL to MySQL synchronization test result. In synchronization at MySQL to PostgreSQL, we have the update transaction type has a higher execution time value compared to insert and delete. That is 0.2031 second for testing with 100 data records and 6.30 second for 10,000 records. In contrast to the delete transaction, which shows a better execution time performance than insert and update. This transaction only takes 0.8 to synchronize 10,000 data records. This is the curve of MySQL to PostgreSQL synchronization process result. And then this is curve of PostgreSQL to MySQL synchronization test result. We can see this, the update transaction has higher execution time value compared to insert and delete. In addition, delete transaction also result better in execution time performance than insert and update. That is the delete transaction. In this test, execution time for update transaction is 0.1829 seconds for testing with 100 data records and 7.2 for 10,000 records. As for the delete transaction, it only takes 0.7 seconds of testing with 100 data. Based on the execution time at this test result that have been described, it can be concluded that the entity relationship method has a shorter synchronization process time when compared it using the MD5 or mixed digits method in previous studies. So the conclusion conclusion is the process of synchronization database management system or DBMS using the entity relationship method can select data that has changed for the synchronization process between heterogeneous DBMS. And then point 2 of the conclusion is the heterogeneous DBMS synchronization method with entity relationship produce a better execution time value compared to the method proposed in previous studies using the Mercedes algorithm. Thank you.